Hello everyone, my name is Nathaniel Ortiz and I'm here today to present automated real-time sorting and storage of recyclable materials and waste. So first I'd like to introduce the problem. In the state of California, recycling centers are closing and further constraining their already limited convenience. This is being paired by a staggering deficit. Saru aims to improve recycling methods by altering what it means to recycle. Current recycling methods are time-consuming, encourage stockpiling, inefficient, and rely on outdated methods to identify recyclable materials. So I'd like to introduce Saru, an all-in-one solution suite for recycling's biggest issues. Each bin features real-time object identification and sorting, data management software, and electronic fund transfer methods to return the CRV value back to the user. So in order to accomplish these feats, we have based our embedded systems around a Raspberry Pi, ensuring enough computing power for our object recognition and communications with our front end and back end. In addition, by using a variety of sensors such as weight, line break, and ultrasonic sensors, we can provide insight into each bin's current status, such as remaining capacity, most frequently recycled materials, and much more. So in order to sort in real time, we selected an object recognition algorithm based on TensorFlow Lite to identify materials as they are inserted into the unit. Other methods of identification, such as barcode scanning and weight lookups, are inefficient and rarely accurate. As a result, these methods are used in our system only for secondary validation. With our model, most materials can be identified in 0.35 seconds. In addition, further expansion will allow us to identify common labels to provide insight into what people are recycling. So here you can see a general overview of our object recognition process. First begins with the object being inserted into the unit. From there, an image of the material is taken and passed to our object recognition algorithm. It will then pass the response to the Raspberry Pi, which allows the unit to place the appropriate material into the appropriate bin. From there, validated images are used to retrain the model. Images that are rejected are subject to a manual review to minimize our rate of false positives and false negatives. Finally, each Saru unit is paired with a client mobile application for users and a web application for firms that the bin is managed by. With the user application, users can ensure that they are paid for their recyclables, as well as access a variety of other recycling-related knowledge and tips on how to recycle. The firm application allows the bin to be managed and provides useful data and analytics into how users are actually recycling. So in conclusion, Saru aims to create a visible environmental impact by changing the way companies and consumers relate to recycling. Our method achieves this goal by increasing the convenience of recycling, reducing labor costs, and streamlining payment solutions, all the while enabling customers to positively impact their community and their environment. We plan to begin initial testing of our prototype in winter of 2021. So thank you a lot for your time. And now we'd like to show you a demonstration of our Saru 1 test harness.
We're going to run through our test with the Saru 1 test harness. Raspberry Pi over here powering everything. We got 3 LEDs, plastic, aluminum, glass. They'll all light up if the object inserted is not accepted by our unit. Internally powered by a camera, and we have lighting in there. So Nathan, go ahead and grab something off the table. Here's an aluminum bottle, aluminum can. Here you go. And it's identified as aluminum. Perfect. All right, let's try something else. All right, La Croix, plastic bottle. Here he goes. Perfect, identified as plastic. Let's try something else. All right, glass. Perfect, glass bottle. Nice Heineken. Oh, put it in there. There we go. All right. Boom, identified as glass. Excellent. All right, let's just try something someone random would throw in there. Oh, pair of glasses. Someone's messing around. Let's see. Here we go. Excellent. All right, rejected. So here's real time. We have the script running. It's a little blurry. There we go. That's the script, but All right, this was the test of the Saru 1 harness.